Good afternoon. How is everyone? Only one JNB joined it. So let's do one thing. Let's wait for another 1 minute or 1.5 minutes. After that, we will be starting. In between, if any of you has doubt, let me know from JNB or Aurangabad. If there is anything you want to discuss, any doubt you have, any question you have, you can ask me. Okay. Okay, so let's start with the class. Done. So what we have studied in the previous class, we were in magnetism only. So we discussed largely what happens when a moving charge is kept in a magnetic field. Done. So there we discussed lots of questions based on that as well. Like 2 classes were dedicated to that topic. It was supposed to be 1 class only, but since you people didn't know anything about this topic, I had to do that. Anyway, in this class, that is why I'm plainly or directly going to start with what value of magnetic field gets generated when there is current in the wire. Okay, so chalo, आज देखते हैं class we will go through theory also, and together with that we'll go through the questions. Okay, so chalo, what things we are going to discuss largely in today's class? So that is magnetic field due to current carrying wire, first thing, and second thing is your Ampere circuital law, right? ये दोनों ही चीजों को discuss करेंगे, and based on these 2 concepts, we will be solving questions. Done. So if you have studied this magnetism, you all must have studied Biot-Savart law. So what this law says actually, it says that if there is a wire, this wire has a current flowing in it. Okay? So if I want to calculate magnetic field because of current in very small section of the wire at certain point P, suppose, done. So suppose I have to calculate magnetic field at this point P, then what will be the value of magnetic field? And yes, also what will be the direction of magnetic field? Okay? So Biot-Savart का जो expression था, that expression was what? P equal to mu naught by 4 pi into I dl cross r, done, divided by r cube, right? So this is this, right? अब यहाँ पे देखो क्या है? This is dl cross r. So what is dl here? dl here is also vector, that is called length vector, है ना? And this length vector will have a direction where it will have a direction in the direction of current. So its direction is in the direction of current. So in the direction of current. Okay. So this is this. So what will be the magnitude plainly because of current flowing in length dl of the wire? So it will be mu naught by 4 pi. If you are going to break it, dl cross r, if angle between dl and r vector is this, done. So angle between dl and r is this theta, right? So if you are going to write that, it will be I mod dl mod r, तो उसको मैं r लिखती हूँ sin theta divided by r. So this will be the magnitude basically. So you all must be aware of this law. Now, how we will calculate the direction of magnetic field at point P? So if value of magnetic field is getting written like this, so its direction will be in the direction of dl cross r. So simple hai, it is in the direction of dl cross r. ahead in the topic, I will give you some a very easy method to calculate the direction. But for now, you just understand from Biot-Savart law also we can calculate the direction. How B will have direction of dl cross r. Yeah? So this is the expression. This is the basic law. And based on this basic law, we derive magnetic field because current flowing in circular coil, because of current flowing in a straight wire, or because of current flowing in cylindrical tubes and all. So for every geometry, we can calculate by using Biot-Savart. Done? So chalo. Field due to circular loop at its center. Again, I'm not going into derivation because this is largely what question discussion session. And again, you don't require that for solving the question. But yes, in your hostels or in your classes or whatever you say at your home, you must try to derive it also. Because you know what happens when we go through derivation, actually, we get comfortable with mathematics of of whatever is involved in the thing. Then, so if you want to get comfortable with solving big and everything, so derivation karna chahiye according to me. But here I'm going to plainly give you the formula. So what if we have a circular coil, suppose. So suppose this is a circular coil, and suppose current is flowing like this, and it is asked that what will be the magnetic field at the center of the coil. So what is the formula for it? If current flowing is R, and if the radius of this coil is, current flowing is I and radius is R, so magnetic field at the center will be how much? Magnetic field at the center will be, formula is mu naught I by 2R. Okay, this is the formula. Now what will be the direction? So direction calculation is very easy. If you have a coil or something like this, so to calculate the direction, what you have to do, you simply curl your finger in along the coil. So in this case, current is flowing in which direction? Current is flowing in anti-clockwise direction. So simply curl your finger in anti-clockwise direction. If I'm going to curl my finger in the direction of current means anti-clockwise, so it will be like this. Then this thumb will give me the direction of magnetic field. And for this case, my thumb is going in which direction? Upward. It means magnetic field at the center is out of the plane. So that is, here magnetic field will be in this direction. Dot indicates basically out of the plane. Similarly, if we have a coil of something like this and current is flowing in this sense, and if you are asking what will be the direction of magnetic field at the center, what you will do, you will curl your finger, 4 fingers, in the direction of fingers of which hand? Right hand. So right hand ko lo, 4 fingers ko lo, magnetic field के direction में curl करो, current के direction में curl करो. So here current is in which direction? Clockwise. So curl your finger in clockwise direction, and if you do this, this thumb is going into the plane of paper. So here in this case, magnetic field will have cross direction, right, into the plane. So I hope you are comfortable with the direction and also with the formula. What will be the value of magnetic field at the center of circular coil, right? So this is the formula. Now for circular arc, अगर question में कुछ ऐसा दिया हुआ है, suppose कि there is an arc, not the whole circle, there is an arc, and you are asked that this arc is making an angle of theta at the center, and the question is find the value of magnetic field because of current I in the flowing in the arc at the center. What will be the magnetic field? So let its radius be R, radius of this arc. It is R. So how we will calculate the magnetic field? Again, I'm telling you here, for the case of circular arc or coil, you can use unitary method. Again, why unitary method? That why reason you will get answered if you will go through the derivation thing. But again, it's not that much important. Important is कि you should know how to calculate magnetic field because of an arc also, right? So यहाँ पे देखो क्या करना है हमें. तो अभी मैंने formula बताया कि because of the whole circle, magnetic field at the center, if current flowing is I, B is equal to how much? Mu naught I by 2R. Done. So whole circle is making how much angle at the center? 2 pi angle, right? So for 2 pi angle, if the arc is making an angle 2 pi, magnetic field is how much? Mu naught I by 2R. If it is making unique radian of angle, then magnetic field will be how much? This much. And if the arc is making an angle theta at the center, then magnetic field because of that arc will be this much. So this is the value of magnetic field because of an arc that is making an angle theta at the center, right? So this will be the formula. Okay, I hope it is clear now. So these are the formulas for circular thing. Okay, done. Now let's go ahead with the question. एक क्वेश्चन पहले इस क्वेश्चन को करते हैं. So for this question I am giving you 2 minutes. Read the question carefully and try to do it. Okay, any problem if you get in between, you can ask me. So take your time, do it please, everyone. And there's so less number of JNVs here. I don't know what people are doing in their schools if they're not reading. Anyway. Is it done? Anyone got answer? Nobody? क्या करना है यहाँ पे क्वेश्चन में तुम्हें दिख रहा है actually this is the current coming, and then what is happening here at this point, current is getting is flowing like this, like this, like this, and at this point what is happening again, both I1 is coming from this side, I2 is coming from this side, so I1 plus I2, again I is going out. So I enters at this point. I enters at which point? Understand the question first. I enters at point A and I leaves the circuit at point B. And in between, what has happened? This I has got divided into two portions because it is going through two paths. Done. So along one it is I1, along another it is I2, right? So this is happening. And we have to calculate magnetic field at the center. How we will do that? So you can see here very clearly, this is one arc, this is one arc in which current is flowing in which direction? Clockwise direction, right? And this is another arc, and here current is flowing in which direction? Anti-clockwise direction. So we have something like this. Done. I got one answer, I guess. Purnima, yes, very good. So we have something like this. Current is entering here, and it is going out here. And in this arc, current is flowing like this, and in this current is flowing like this. This is I2 and this is I1. So you have to calculate magnetic field at the center. What will be it? It will be because of these two arcs, right? So first try to see their directions. So if I see because of I1, current will be in which direction? Sorry, magnetic field will be in which direction? So again, what you will do, curl the finger in the direction of current. That will give you the direction of magnetic field at the center of the arc. So because of I1, I'm going to do. So I1 current is flowing in clockwise sense. So move your finger in the clockwise sense. This thumb is going into the plane of paper. So magnetic field because of I1 is magnitude तो भी नहीं लिखा मैंने, direction लिख रही हूँ inward. ठीक है? And what will be because of I2? If you're going to see, because of I2, it will be how much? In which direction? So again, current is flowing in which direction? Anti-clockwise. Anti-clockwise. If you're going to curl your finger in that sense, then magnetic field is coming out of the plane of paper towards me. That is out of the plane of paper. So because of second current, direction is inward. So overall, magnetic field because will be what? Subtraction of these two. We need subtract them, right? पहले magnitude लिख लो. So because of I1, magnitude will be how much? How much is going to be? Formula क्या है? Mu naught I1 by 2R. पहले ये लिखो. उसके बाद whatever angle it is making at the center. So कितना angle ये बना रहा है? चलो अभी के लिए मैं इसको θ1 मान लेती हूँ. That is clearly 3 pi by 2. But यहाँ पे मैं θ1 लिख रही हूँ. θ1 by क्या लिखोगे? 2 pi. Again, what will be the magnetic field at the center because of second arc? So again, not second arc में current क्या flow कर रहा है? I2 2R θ2 by 2 pi. This is value of current. This is value of magnetic field, right? Now we need to calculate I1 and I2. So I1 and I2 we need to do very carefully. अगर आप ध्यान से देखो तो यहाँ पे I ऐसे आया है ना? So what is happening? It is getting divided into two parts. So एक part का कुछ radius होगा, and second part will also have some radius. Write it like this. ठीक है? This is I1 current is going in this part, and I2 current is going in this part, right? So we need to calculate I1 and I2. Suppose its resistance is R1 and its resistance is R2. So I have told you how you will divide the current. कैसे divide करेंगे? I1 का value क्या लिखोगे? चलो यहाँ से लिखना start करते हैं. So I1 का value क्या लिखने वाले हो? I will just calculate one, or let's do for the both. So I1 क्या होगा? I into, I have told you if you have to calculate current in this branch, first write total current, then write resistance of another arm, that is R2, and then in the bottom write sum of both the resistance, right? So I1 is this. I2 क्या हो जाएगा हमारा? Accordingly if you will do. So that is I into R1 by R1 plus R2. Done. So in both the expression, you can see that I by R1 plus R2 constant same है ना? In I2 also there is a term I by R1 plus R2. What is different? R2 and R2. Done. So what will be the value of R2? Again देखो ये इसका resistance क्या होगा इस arc का? So its resistance value will be, किसी का भी resistance if you are going to write, its value will be how much? R equal to rho L by A. Done. So both these wires have same cross-sectional area. So A is same for both the arcs. Also rho is same because they are made of the same material. L is different because they are making different angles at the center. So their arc length is different. L is different. Again, L will depend on what? If there is an arc making an angle theta at the center, so L will depend on what? L will depend on theta. If theta is 2 pi, arc length will be 2 pi r. If theta is theta, then arc length will be theta into r. Done. सो यहाँ पे एल का वैल्यू आप क्या लिखोगे, रो बाई ए, एल क्या हो जाएगा, थीटा इंटू आर। सो आर को स्मॉल आर में लिखती हूँ, ठीक है। सो दिस इज योर थीटा इंटू स्मॉल आर। नाउ व्हाट यू आर गोइंग टू राइट हियर, रो बाई ए आर, दिस इज कांस्टेंट, या दिस इज कांस्टेंट फॉर बोथ द आर एंड योर थीटा। सो R1 वैल्यू को आप क्या लिखोगे और R2 को क्या लिखोगे, अब मुझे ये बताओ। I बाई R1 प्लस R2 कॉन्स्टेंट है, इसको मैं K1 लेती हूँ। R2 को मैं क्या लिखूंगी, रो बाई ए स्मॉल r, that is radius of the earth, and sorry, radius of the coil here, and theta is how much for I1, I1 theta के लिए यहाँ पे ये थीटा कितना बना रहा है, that is theta 1, तो इसको theta 1 ले लो। Here R2 we need to calculate ना, तो R2 के लिए क्या थीटा लिखोगे, ध्यान से लिखना सही से, गलत नहीं होना चाहिए। So what theta value you will be writing here, theta 2, क्योंकि we are calculating R2, so R2 will be directly proportional to L2, done. So that is theta 2. If you are going to calculate I2 here, so I2 value will be how much, I by R1 plus R2 को K1 लिया, K2 theta 2, and this is I2 is how much, K1 theta 1. Now put these two values in the above expression. If you are going to put the value of I1 in from here, what it will be, put it carefully. देखो ना करने की जरूरत नहीं है, मैं इतना इसलिए एक्सप्लेन कर रही हूँ so that you can understand logic, ठीक है, बट यहाँ से क्लियरली निकल जाएगा। देखो म्यू नॉट बाई 2r है ना, इंटू 2 पाई, तो यहाँ पे 4 कर दो, 4r मल्टीप्लाई कर दिया, 2r इंटू 2 पाई, म्यू नॉट थीटा 1 लिखो। I1 का वैल्यू क्या लिखोगे, I1 इज इक्वल टू हाउ मच, K2 थीटा 2, माइनस क्या करोगे, दोनों मैग्नेटिक फील्ड का डायरेक्शन ऑपोजिट है, सो आई विल सब्सट्रैक्ट देम। नाउ व्हाट इज थीटा, B2 निकाल लो, सो म्यू नॉट बाई 4 पाई r, एंड व्हाट विल बी द आंसर, theta 2 is already here, and that will be K theta 1. So what you can see now, you can see here the value of magnetic field, net magnetic field will be 0 because both are equal, right? So it will be 0. Done? Everyone clear? Okay. JB विशाखापट्टनम वाइजैक, क्या हो गया, इतने लेट क्यों आ रहे हो, आधे क्लास तो चले खत्म हो गए, then you are coming so late. चलो, I hope it is clear. If this question is clear, anyone having any doubt? I tried explaining it so much. I have explained every bit of thing, and I could have done it directly, but I went through this so that it can be more clear. चलो, ठीक है. Now, field into a straight wire. This is another concept. जैसे अभी तक हमने कौन से concept को पढ़ा? If there is current flowing in a circular coil, what will be the magnetic field? And because of circular arc, also what will be magnetic field at the center? That is done. Now, what will be magnetic field because current flowing in a straight wire of certain length L, suppose, at a distance A, suppose. Here we have to calculate the magnetic field. How we will do that? So what's the process actually? देखो derivation तो important होता है for better clutch at mathematics actually, क्योंकि that boost your confidence. Testing. यहाँ पे मैं सारे ही logics बताऊंगी which is required for solving questions related to magnetic field because of current flowing in a straight wire, right? तो यहाँ पे देखो what is going to happen, what will be the formula because of this. तो मैग्नेटिक फील्ड का फॉर्मूला होने वाला है म्यू नॉट बाई 4 पाई, I is current flowing in the wire, A is what, A is distance of this wire, distance of this point from the wire, perpendicular distance actually you have to take, this is A, so this is A. Now this angle, actually you have to be careful about the angle only. Angle measurement is done from where, first thing. So angle measurement, जैसे अगर तुम्हें इस कॉइल की वजह से यहाँ पे मैग्नेटिक फील्ड निकालना है, so the first thing that you have to do is join the end point of wires to the point P. So one end point is this, another end point is this, join these two to the point P. ठीक है, तो हमने इसको क्या किया, join कर दिया. Now you have to check for the angles. Angle measurement you will do from this line. Yani ki this is the reference line for measuring angle. Okay, this is the reference line for measuring angle. So angle measurement from here. Again, you know that if we measure angle in the clockwise direction, if we measure angle in the clockwise direction, it is taken as positive. If we measure angle in anti-clockwise direction, it is taken as negative. यहाँ पे देखो, this angle is theta1, this angle is theta. So which angle by sign convention will be positive and which one negative? So theta2 we are measuring in, measurement will start from where? From this line. Okay. So start measuring from this line. So this is theta2. We are measuring in which direction? Clockwise. So it is positive plus theta2. And this we are measuring in anti-clockwise direction. So that is negative. इसलिए यहाँ पे लिमिट में है minus theta1 to theta2, right? Now if you are going to solve it, it will be mu naught by 4 pi I by a. If you are going to put the limit simply, so it will be sine theta1 plus sine theta. So this is the formula, right? This is the formula. Now what will be the direction? This is the magnitude of magnetic field because of this, right? What will be the direction? So if current is flowing in a straight wire, suppose in the upward direction, you have to calculate the direction of magnetic field at certain point. What you need to do now? Now take your thumb of your right hand along the direction of current, okay? And curl your finger. So now what is going to happen? Curling finger will give you the direction of magnetic field, right? So if this is the straight wire, current is flowing like this. So magnetic field direction will be something like this, something like this. Okay, something like this. But if you have to calculate the direction of magnetic field at certain point, then you just see here current is flowing in this sense. And if we put our thumb in the direction of current, then this forefinger, this side is going into, and this side it is coming out. दिख रहा है ना? ऐसे है, देखो इसमें करंट ऐसे फ्लो कर रहा है in the upward direction. Put thumb, right hand thumb along the direction of current. This finger is pointing inward and here it is pointing outward. So this, in this space, magnetic field is in inward direction, and in this space, magnetic field is in outward direction. So here magnetic field because of this current will be in inward direction. Okay? So this is done. Magnitude you can see like this. ठीक है, तो यहाँ पे देखो साइन कन्वेंशन में तुम्हें पढ़ना नहीं है, इस तरह के क्वेश्चन है. ठीक है, सिंपली यू राइट द फॉर्मूला mu naught by 4 pi I by a sin theta1 plus sin theta. But later I will let you know कि where you need to be careful about sign convention, right? So let's see that. अब देखो यहाँ पे this is again very simple. So if there are various cases, right? Here the wire is what of finite length, its length is capital L. Suppose this is a semi-infinite wire. If you can see here, this is semi-infinite wire. Here, its length in this direction is extending to infinity, and in this direction, its length is ending here. So this is semi-infinite wire. Now, if you have to calculate magnetic field at point P because of this wire, what you will do? Just say, if its length is finite, then another end will be this, and you will keep it like this. जैसे अभी जो हमने देखा, current was flowing in this wire like this, and if we have to calculate magnetic field at point P, what if we were doing? We were simply joining end point of wire with the point P. Now suppose what, and we were drawing a line perpendicular to it. This was A, right? So this angle was theta1, this minus theta1, and this was theta, right? Now what will happen if I'm going to increase the length of wire? So suppose I have increased its length to this limit. So now theta1 will be this, then this. So theta1 is increasing. You can see here. Again, I'm increasing its length more. Again, what is happening? Theta1 is increasing more. So if I make it of infinite length, then what will happen? In this sense, this angle will increase up to how much? 90 degree. Similarly, if its length we are increasing in this direction also, what will happen? Theta2 will also increase. And if its length is infinite in this direction also, then theta2 will become 90 degree. So for infinitely long wire, then magnetic field will be how much? Mu naught I by 4 pi A sin theta1 means sin 90 plus sin 90. ठीक है, for completely infinite wire, right? So this is equal to mu naught I by 2 pi a, क्योंकि sin 90 1 होगा, 1 plus 1 2, 2 by 2 pi a, तो एक 2 कट हो जाएगा. So this will be the thing. Now, if the wire is semi-infinite, in that case, what you will do? So see here, in this case, one end of the wire will make an angle of 90 degree, but another end is here, and perpendicular is also this. Done. So this line is making what angle with this line? 0 degree. And they are overlapped over each other because we have to calculate magnetic field at the point P. तो हम क्या करेंगे यहाँ पे? Perpendicular draw करेंगे. P point से wire पे, है ना? So another end is here also, and that perpendicular line is this also. So angle is 0 degree. So in this case, what is going to happen? Magnetic field will be mu naught I by 4 pi a sin 90. One angle is 90 and another angle is 0 degree. Sin 90 plus sin 0. Sin 0 is 0, sin 90 is 1. So 1 plus 0. What answer you are going to get? Mu naught I by 4 pi. So remember, if wire is infinitely long in both the direction, in both, completely infinite if it is, then magnetic field will be this. If it is semi-infinite, that is, if it is ending from one end, then magnetic field because of that wire at this point will be how much? Mu naught I by 4 pi. For different points, if you're taking the point P here, then again one angle will be 90 degree, but another angle will become different. क्योंकि आप तब क्या करोगे? यहाँ से perpendicular draw करें, है ना? So according to question, you will proceed, right? चलो. Now, field due to straight, again, if the point P is lying along the length of wire, what will happen in that case? If it is something like this, what will be magnetic field at point P? कोई भी बताओ जल्दी से क्या होगा? What will be magnetic field at point P because of this wire? P is lying in the direction of wire, or you can say it is just in the line of wire, right? So what will be its value? First, let me know. It's raining here. Yes, I'm waiting for you people. Let me know the answer. आज YouTube पे सारे लोग शांत बैठे हैं. What happened? Nobody answering, nothing. Let me know what answers you're getting. You don't need to do anything. You just use Biot-Savart law, है ना? B equal to क्या होता है? Mu naught by 4 pi. What is this? I dl cross r by r cube. If you look at the point P carefully, suppose कर लो, you are going to calculate magnetic field first because of a small length of the wire. Take any length dl. Magnetic field because of this dl length at point P will be how much? So position vector of point P with respect to dl will be this. This will be r, right? And dl direction will be in the direction of current. So dl direction is this, r direction is this. Angle between these two is how much? 0 degree. So cross product between two vectors which share 0 degree angle will be how much? A cross B. If you are going to do an angle between A and B is 0, then you will write it like this, na? Sin 0 is 0, so cross product will become 0. So if because of a small element of this wire, magnetic field at P is 0, so because of all small elements you are going to take, magnetic field at point B will be what? 0. So just keep this in your head. If there is a wire like this, and if you have to calculate magnetic field along the length of wire, then if any point you are taking on the length of wire, at that point magnetic field because of current in the wire will be what? 0. Okay, done. So keep it in your head. Now do this question, everyone. I'm giving you some 2 minutes. Chalo, de hi diya, 2 minutes. But I need answer from everyone. You just need to put the formula, do the calculation. Do it now. Everyone do it. Yes, I'm here only. Don't worry. If you have any doubt or anything, if you're not able to understand the question, then also you can let me know. Yes, I hope you all are doing it, not simply sitting. I can only hope, there's nothing else in my hand. That's the misery of online classes. Teachers can only bark from distance. They can't do anything substantial in terms of if students are not being regular, punctual, not paying attention, can't do much. We can only deliver the concept, So if your education is rely on this online mode classes, you should carry extra measure of sincerity, punctuality, and everything. It's very much required because, like, teacher is not just in front of you to guide you, and so ये responsibility you people should take, when we are made more free, also extra responsibility come with us. Just now you are free to look here and there and do whatever you wish. But again, at the same time, responsibility comes in your hand. What sort of responsibility? To learn the concept that is getting delivered. So do that. चलो आंसर बताना मुझे सबका ही आना चाहिए. I am expecting on a wall because simply you need to put the formula, get the answer, do it. Purnima, Kamini, Kavita, Kalyani, all are using the same system, right? These four people together, I guess. Okay. कोई आंसर नहीं. This should not happen. Yeah, this is a huge disappointment. Come on, let me know the answer. Okay, चलो कोई नहीं. मुझे करना होगा. So what the question is given, the magnitude of magnetic field at the center of an equilateral triangle loop. So there is a triangular loop, and this triangle is of what nature? This is an equilateral triangle. And what value of current is flowing through this loop? 10 ampere current is flowing through this loop. And you have to calculate magnetic field at the center. So you have to calculate magnetic field at the center. What you can do? How you can solve? how to apply the formula? Simple है, देखो यहाँ पे ध्यान से. You can feel like or you can see it like this is made of 3 rods. You know, एक rod is AB, another rod is BC, and third rod is what? CA. So it is made of 3 rods, right? And Purnima, yes, very good. So 3 rods are done, and there are straight rods. Done. So if we can calculate magnetic field because of one rod at this point, then because of another 2 rods, the magnitude of magnetic field at the center will be same. Why same? Because this is an equilateral triangle. Distance of any side from the center will be same. Distance of any side from the center is going to be same, because this is symmetrical, right? So this distance is going to be same. Or direction will be what? Since current is flowing in one sense, that is, if you see here, current is flowing from AB to BC to CA. So in one sense, it is flowing like this. Done. It means current is flowing in in a clockwise direction. Done. So magnetic field, if current is flowing in a clockwise direction, magnetic field will be inward, right? So magnetic field, because of all these 3 rods, will be in which sense? Direction inward. Now magnitude कैसे निकालोगे? तो सिंपल है, किसी एक रॉड के लिए निकालो, तीनों के लिए सेम वैल्यू होगा. So how we will calculate because of any one rod? We have to calculate magnetic field at point O at the center of the circle. So draw perpendicular line from this point to the rod. एक rod पे मैंने draw कर लिया AB, and current is flowing in this direction. Now to calculate magnetic field because of AB at O, what we will do? We will join its 2 ends to the point O. So if you're going to join 2 ends to the point O, it will look something like this. What will be this angle and what will be this angle? So this is an equilateral triangle. And if you can see, if you know the properties of triangle, you can see very clearly this whole angle is 60 degree, and this will be 30, this will be 30, and this will be what? 30, and this will divide it, right? So this is 30, this is 90, so this angle will become 60 degree, and this angle will become 60 degree. So theta 1 and theta 2 value is how much? 60 degree, 60. That is done. Now we need to calculate this distance, and D. So formula of magnetic field is what? Mu naught I by 4 pi t sine theta 1 plus sine theta. So theta 1 and theta 2 value we already know now. Theta 1 is 60 degree and theta 2 is also 60 degree. That is known. Now let's calculate D. तो D को भी आप बहुत ही easily calculate कर सकते हो. Let's navigate through this triangle. This triangle. If you can look at this triangle, इसको P मान लो, तो OP by PB, OP by PB किसके बराबर होगा? tan 30, है ना? And OP value we need to calculate. Call it Y. PB is how much? This is the perpendicular line on it, and drawn from the center of circle. So this is basically bisecting the side AB, and AB length is how much? Suppose it is AB length is A. So length of PB will be how much? A by 2. So A by 2, and this is equal to 1 by root. So Y is equal to how much? A by 2 root 3. Put the value and get the answer. So what is it? Mu naught by 4 pi I by how much? A 2 root 3, and sine 60 is how much? Root 3 by 2 plus root 3 by 2. So that is 2 root 3 by root 3 by 2 plus root 3 by 2. So क्या लिखोगे आप? 2 root 3 by 2. And this is going to be thing. So this is this. Mu naught by 4 pi is 10 to the power minus 7. I value is 10 ampere. A is 1. And this is 2 into root 3 into root 3 is 3. So 3 into 2 is 6. 6 into 10 to the power minus 6. Now this is because of one part of the one portion of the triangle. Such 2 more portions are there. So net magnetic field will be 3 times this one. Done. So it will be how much? 18 into 10 to the power minus 6 Tesla. Done. So this is 18 microtesla. Tesla is what? Unit of magnetic field. You already must be knowing it, I guess. So this is this. Now do this question and let me know, please. This time I don't want any disappointment. Solve it. I'm giving again 2 minutes to you. Solve it and let me know. Yes, all Jainvi, Warangal, Sonali, Purnima, you gave answer last time. So Mahisagar, Vizag, Purnima, Kamini, Kavita, everyone. Okay, answer is correct. I hope you all must have solved it. Jainvi, Raichur, Gondia, Chikbalpur, Bhavnagar, Aurangabad, Ahmednagar. Some Jainvis are very peacefully silent. I don't know, peacefully or not just peacefully. Maybe your mics are off, but in the background, you all people just making noise, talking and all. वही सीन होगा मुझे पता है. I know JNV Chikbal. Okay, okay, correct. Others, please come on. Take the pain of writing answers in the chat box if you have taken the pain of solving the question. चलो करो, मैं वेट कर रही हूँ, कोई चाप नहीं. Chap means tension, no tension. Take time, do it. Question is too easy. You just need to apply the formula, whatever I have taught till now. And nothing more you need to do, right? Chalo, more answers I'm waiting for. On YouTube also, please let me know यार, सभी शांत बैठे, no messages, nothing, no answers, no response. क्या है ये? इतनी शांति क्लास में अच्छी नहीं लगती. There should be some noise. So drop some noise in the chat box. So I'm going to make one poetry today on the topic, make some noise in the chat box. Okay? And I will share that with you people tomorrow in the chat box. तो जल्दी से बताओ क्या आंसर आया. Fast. Those who will join on time tomorrow, they will get to read that poem. And those who are coming late, they won't get to see that. I'm sorry for those people. जल्दी से आंसर बताओ क्या हो रहा है. This should not happen, my dear. This should not happen. मतलब क्या कर रहे हो तुम लोग? Seriously? No answers? Oh my God. तुम लोग after class, you people are not reading. I can say that with 100% surety. And even if you are reading, even if I'm wrong, and you are reading, not reading properly or not in the right direction. Maybe you people are putting in effort, maybe. But follow the instructions now, whatever instructions you're getting from your teacher. Like in the previous week also, I told you on Sunday, I will be discussing this topic. So what you are doing now? You didn't go through, and you didn't require to go through also. Even if you were attentive in the class, you would have done it. But I feel like you people were not paying attention. Chalo, theek hai. So यहाँ पे two identical wires A and B, each of length L, carry the same current I. ठीक है, we have two wires carrying current I, and both these wires have same length L. One wire of L length is bent to form a circle, done, and magnetic field at its center is written as BA. So what will be the value of BA? Mu naught I by, क्योंकि current will be I only, mu naught I by 2R. What will be the value of radius of this loop? That we need to calculate. And here, what will be the shape? Here we are molding it to, like we are bending it to form a square. Now, this square will have some will have side of some length, right? And magnetic field at the center is written as what? B, B, right? And it will be how much? Mu naught by 4 pi sine 4 pi d. D will be this sine theta 1 plus let me discuss it anyway. तुम लोग सोचोगे मैं क्यों लिख रही हूँ ऐसे. So let's first calculate BA, right? So BA you can do very easily from here. Mu naught I by 2r. Radius you can calculate, right? Its length is how much? L. So L will be equal to how much? 2 pi r. R will be equal to how much? L by 2 pi. So BA value will be how much? BA value will be mu naught I by 2. Radius value is how much? L by 2 pi. 2 will get cancelled. So BA is equal to mu naught I pi by L. Mu naught I pi by L. So this is BA. We need to calculate magnetic field at the center of this square. So side of this square will be how much? Length of perimeter of this square loop is how much? L. So this will be equal to 4 into each side. That is small L here. I have taken. So small L value will be how much? L by 4. If you have to calculate magnetic field at the center, how you will calculate? You will simply use the formula, right? Aniket, hi, but how this hi is going to help me? Ye mujhe batao. Answers you people are not letting me know. Just hi is not going to let everything go in the proper way, na? But still, hello. Anyway, यहाँ पे को क्या होगा? Magnetic field at the center will be because of 4 rods, current carrying rods. One is this AB, another is BC, another is CD, and another is BA. So first calculate magnetic field because of any one. So because of one, if I'm going to calculate, I will write mu naught I. Current flowing is same in all. Mu naught I by 4 pi D. D, this will be D. So this will be how much? This whole is small l. So half of this will be L by 2. So 4 pi L by 2 into how much angle its end will make at the center. Since this is a square में अगर तुम लोग जाओ ऐसे तो इसके सेंटर पे ही कितना एंगल बनाएगा ऐसे. If this is bisecting this one, this will be 45, this 45, this is 90, this will also be 45. Simple geometries these are. I don't need to go much deeper. So sine 45 plus sine 45, right? So this is this. Now if you're going to solve it, mu naught I by 2 cancel kar do. So this is 2 pi L. Sine 45, 1 by root 2 plus 1 by root 2. So that is 2 by root 2. Done. And if we have to calculate the total value of B, like BB, if we have to calculate, we will multiply this with 4. 4 into mu naught I by 2 pi L into 2 by root 2. So this is going to be how much? This is going to be your 2 and this is 2 root 2, right? So mu naught I by okay, L ka value मैंने यहाँ नहीं लिखा. This is small L, right? So we need to put the value of a small L in term of capital L. So that we will do later. Okay, don't worry. Mu naught I by what I will write here? Pi L. Mu naught I by pi L into 2 root 2. Now what is the value of this small L? Value of it is mu naught I by pi L by 4. So L 4 ko upar le jao. So that will become 8 root 2. Then if you're going to take their ratios, you will get D as the answer, right? So what will be the correct answer? Correct answer will be D. Okay. So one thing I will say, you people are not putting in more effort. And that is why, like today also, I can't discuss many questions. I can only discuss 4 or 5 questions and some concepts. I could have done more if you would have replied on time. Ajay, क्या हो गया? क्लास एंड हो रहा है. एवरीवन इज कमिंग विथ बिग हाई. क्या हो गया? क्लास टाइम पे आते नहीं हो, लेकिन सबको लास्ट में मतलब like everyone is more inclined towards telling bye, not hi, because at the last time coming and telling hi, it means you are telling bye. Done. Okay, ठीक है. कल की क्लास में we'll be meeting with what? We will discuss Ampere circuital law. Done. That we will discuss, and this is very important law, just like Gauss's law in electrostat. We will solve question based on that also. And further, we will discuss, after that, we will discuss what? Magnetic moment because of current carrying, magnetic moment because of current flowing in circular loops or in a square loop or in a rectangular loop or whatever shape the loop is having. Okay. So that we will discuss. Two things we are going to discuss tomorrow. Done? चलो तो अच्छे से तुम लोग रहो और अपना ख्याल रखो एंड डू solve lots of questions, do work properly, don't ignore classes, come on classes on time so that you can utilize each and every things properly. Okay, this class is for you only, and so you should use it, utilize it. Okay.